this second video, we'll be looking at what transformations of exponentials and logarithms look like algebraically. Now, there are going to be 3 slides here, each with about the same amount of stuff you see written right here. So you might want to take a chance at the beginning of each slide to quickly pause the video, write down everything, and then follow along as I annotate. On this first slide, we'll be looking at just vertical stretches and compressions. And we'll start by looking first at just a generic function f of x. So if we start originally with some function f of x, and we want to do a vertical stretch or compression to get to some new function g of x, all we actually end up doing is multiplying f of x by some a value out front. Now, we've talked about this before. If the size of a is greater than 1, then we would say our function was vertically stretched. If the size of a is less than 1, then our function has been vertically compressed, in both cases by a factor of a. So let's jump into what that looks like for exponentials. If we start again with our parent function of f of x equals 2 to the x, and we want to vertically stretch by a factor of 3, well, that means that a is 3. So we just put that times 3 out in front of our function 2 to the x. For a vertical compression, in this case by a factor of 1/4, and that's still our a value, we just again put that times 1/4 in front of our exponential. Moving on to logarithmic functions. If we start with the parent function of log base 2 of x, and we want to vertically stretch by a factor of 3, well, it looks a whole lot like what it looked like for the exponential. You just multiply times 3 out front. Same idea for the vertical compression by a factor of 1/4. You just multiply by 1/4 out in front of your log. For vertical translation, these are also fairly straightforward. Just for your generic function, if you start with some function f of x, and you want to shift it up or down, so vertical translation, you add some constant k on at the end. If k is positive, in other words, we're doing plus 5, that's a shift up. If you're doing minus something, like minus 2, that's a shift down 2 units. So if we look at a couple examples for exponentials, we'll again start with a parent function of 2 to the x. If we want to translate up 3 units, we just add on a plus 3 at the end, right? This 3 is our k value. If we want to shift down 4 units, well, instead we just do minus 4, negative minus 4 because it's down. For logs, it works out pretty similarly again. We'll start with our parent function of log base 2 of x, and if we go up 3 units, we just do plus 3 way at the end of our function. If we want to do down 4 units, we just do minus 4, right? Again, minus because it's down. Horizontal translations, I think, are the trickiest to work with, so let's take a look. If we start with an original function f of x, in order to do a horizontal translation, what actually has to happen is that we replace that x with x plus or minus some number. Okay, so instead of, remember, think back to quadratics, if we want to shift to the right by 2, we would, instead of having x squared, have x minus 2 squared. The other tricky part about horizontal translations is they do the opposite of what you would expect. So in order to go to the right 2, like we just said, you have to do x minus 2. In order to go to the left 2, you have to do actually x plus 2. So what does that look like in exponential functions? Remember, in exponentials, our x is actually in the exponent. So in order to shift left or right, we actually end up changing our entire exponent. For example, in order to go to the right by 3 units, instead of just having an x in the exponent, now we would have x minus 3, all in the exponent. In order to go to the left by 4 units, we would, instead of having x in the exponent, have x plus 4, again, all in the exponent. With logs, it works a little bit differently. Right, if we start with a parent function of log base 2 of x, remember in this case, x is inside of our log. So in order to move to the right by 3 units, instead of having just x inside the log, we would have x minus 3, all inside of our logarithm. In order to go to the left by 4 units, we would have to, instead of having x inside the log, have x plus 4 all inside the logarithm. The important thing to remember for horizontal translations is you have to replace x with x plus or minus whatever translation you want.